surveys?
Only for the classes.
Yeah, like your class evals.
Yeah.
But how many of you guys have ever clicked on one of those surveys that pop up at the top of Canvas? Anybody here? You can admit it if you. Yeah? So I always get like 2 or 3 people in each class, and they're just like survey takers, and they're just like, I take all the surveys. I've never done one. Never.
I don't want to know it's too long, so
Yeah, right? It's just X, no thank you. So the problem with doing it with surveys, one thing to think about is if you allow people to decide whether or not they want to participate, you run into that problem. So anybody want to guess what our percentage is on response rate on those surveys at CBC? It's like 3.5% to 5%. Yeah. So the response rates are very, very low on voluntary response surveys. And so it's not always the best strategy, but sometimes it's kind of it's the best you can do. I can't force people to answer my questions on a survey, you know. So anyways, but it's not a bad strategy. What else? What would be another way you could try it?
Have like 10 people go into random classes and just take down their opinions real quick.
Yeah, you could try just doing it in the classroom because at least you know everyone there's a student. But who would you miss if you did that?
Times of day.
Yeah, it depends on time of day. You might miss people. What else? Well, yeah, I mean, some people just maybe won't be there. And it would actually probably matter, like, when in the quarter you went. Because, like, I guarantee you right now, attendance is way higher than it's going to be in, like, 7 weeks. Because attendance just drops way off around, week 7, 6, 7, 8, and then it pops back up. So, anyways, yeah. So the point, though, is that when you're considering how to get your samples, it matters a lot how you collect it. Because you really don't want to accidentally leave people out. So if I really care about all students, then I need to make sure that every single student has the opportunity to participate. Same with or maybe I only care about all drivers. But then everyone who drives a car at CBC needs to be, have an opportunity to get picked. That's the idea. I don't want to set up my sample in a way that accidentally screens people out. Okay, because then your results are going to be biased. And so the gold standard is what we call a simple random sample. So this is kind of a side. But what a simple random sample is, and sometimes that'll be abbreviated. So a simple random sample. So that's SRS. So the way that you take a simple random sample is in such a way that everyone has an equal opportunity or likelihood of being picked, such that each individual in the population has an equal chance of being included in the sample. So everybody has basically an equal opportunity to end up in the final sample. So some things that wouldn't be simple random samples would be like if you just went to a parking lot and then you just pick like the first car and it's just like at a certain time of day or something. So that wouldn't be a simple random sample because there's a lot of drivers that won't be there at that time, and so you would be it wouldn't be a simple random sample because everybody's had the same chance to be picked. What about the survey? If you post a survey on Canvas, do you think that satisfies simple random sample? It actually doesn't. Why?
Not everyone has access to a computer.
Well, you have an access issue, but even if everyone got an invite to take the survey, is it a simple random sample?
No, but only people choose.
Yeah, it's because only the people who choose to participate can end up in your sample. Because basically, like, if you give a survey on Canvas, there's a 0% chance that you'll get me in your sample because I don't take Canvas surveys, right? So it's not necessarily about equal opportunity to participate. It's about equal chance. You don't want to give people that option. It's like, if I pick you to take my survey, I'm going to do everything in my power to make you take my survey because you got picked. So you want to give people as little choice in the matter when you're taking a simple random sample. So how could you actually take one, do you think?
Select the student from every class every hour.
What's that?
Select the student from every class, like every hour maybe.
So you could randomly select a student from every single section at CBC, and just like that one student, and I'm going to pick one person out of every class, and then boom. And that would, as long as you did the online sections and everything like that, then that would be a simple random sample because everyone would have an equal shot, more or less, of being picked. Yeah, so that'd be simple. Now, how do you pick the student out of each classroom that you're going to talk to, though? Random, but how do you do that?
Close your eyes.
Over the hat.
Yeah, so exactly. Yeah, so the most simple way, right, is draw names out of a hat, because that's essentially what you want random sampling to be like. You want it to be in such a way that it's as if someone just had a big bucket of everyone's name and they just pulled out some names and said, "You're in, and I'm going to talk to you." Okay, that's a simple random sample. Of course, names from a hat is exceptionally inefficient, and so how do you think we probably do it instead?
Random number generator.
Yeah, we use random number generators in computers. And so there's a lot of programs out there that can help you generate a random sample. And they're just using like some random number generators built into the computer. Excuse me. So I linked one in the comment, or in the module 1. So down here in section 1.2, I had linked something called random sample generator. So I'll show you kind of how it works. I actually embedded it in Canvas, so you don't even have to. I thought it linked out, but apparently it doesn't. But here's the way that the random number generator works. You just tell it what you're looking for. So to gather a random sample, essentially what you do is you just assign everybody a number. So like student IDs could be your number, or we could just label everyone like 1 to 7,500 or something. But everyone gets a number associated with them. And then you just tell the random number generator how many people you want to pull and what the ranges are. So like here, we'll just do one set because you could actually generate multiple samples. And let's say we're going to do it in this class, right? And I wanted to pick some of you guys to take my survey. So today, let's just count how many people are here. Somebody else do it for me too, though, so I get it right. So 3, 4, 5. I feel like I lost count. Is it 29?
I lost count too.
Such a simple task. Why am I so bad at it? 29? Okay. So everyone would basically get a number from 1 to 29. So I just number you all, and then I would just decide. So let's say I wanted to pick 7 of you, right? So I would just tell the computer, give me 7 people in my set. They range from 1 to 29. Now, one thing it says, do you wish number in a set to remain unique? What do you think that means?
So a number can be picked twice.
Yeah, it's like, are you going to allow it to be picked twice or not? Because, so like there's 2 ways to pick. And we call it like with replacement or without. And if you're picking people, you definitely don't want to repeat the same number twice because I want individuals. And so I would tell it, I want every number to remain unique. I don't care if it's sorted. And then I just boom. And then it just produces it just uses a random number generator and my constraints, and it tells me, okay, here's the people you pick. So go talk to person number 25, 1, 7, 10, 2, 5, and 9. And that's who you should talk to. So then I had no chance to like introduce my own bias or anything like that into it. I used a process where everyone had an equal shot of being picked, and so it's just like, boom, those are my people, and those are the ones I'm going to talk to. That make sense? Yeah. And if we did it again, what do you think would happen to our selection?
Change.
Yeah, you're going to get a different set of values because it's going to be pulling different values out of its random number generator. So, okay? Make sense? So in reality, that's how we actually do simple random samples. We just do it electronically. And like Excel can do it, and there's a bunch of programs that can do random sampling. But you can also, there's like on Google, there's tons of links where you can just boom, 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 and then it'll do it for you. So, okay. So that's what I was just telling you right now. So I don't have to write anything on that slide because I just showed you how you can use technology to get a simple random sample. Okay. Everybody seem okay with that? Does that make sense? And the whole point is, this whole time is you're just trying to get that representation of your population to show up inside your sample. And you don't want to accidentally screen people out and have bias into your results. That's the idea. Yeah, right. Yeah. So you want to make sure, yeah, exactly. So there are some other, sometimes a purely simple random sample is not super convenient. because it's not exactly easy to get people's, like if I try to put every CBC student into a big pool and then I pull like 150 of them, it might be really hard to go track down 150 individual students. I don't know where they are, I got to find out where they are and all this stuff. They're probably not going to answer their emails. So sometimes we'll use other approaches. So in a stratified sample, it's kind of like a two-part sample. What you do is you split your population into groups. And usually, the groups you pick are going to be, I didn't want to end that yet. Usually, they're going to be picked in such a way, like, because the groups have some significance. So usually based on some characteristic of importance. So, like, if I'm going to do a stratified sample, some surveys will split their population into like demographic information. So you split it. That might be the way you split your population. Maybe you split your population on like online versus face-to-face students or something like that. You can do it however you want. And then what you do is you take a simple random sample from each group, and the groups are called. Sometimes they're called strata or stratum, and that's why it's called stratified sampling. But you can kind of think of it as like group sampling or something. So basically, you split your population into groups, and then you go into every single group, and you take a little simple random sample in that. So it's like if I'm talking about math classes, maybe I just split all math students by like what class they're in, and then I go into each class and take a simple random sample. That's a great question. Probably usually up the top right, bottom strata in parentheses. Yeah, that's strata. That's just another. That's just I think it's Latin, and that's just why I just only wrote it so that you know why it's called stratified sampling.
Oh.
Because strata just means groups or like levels. So. Okay. All right, so that's one way you could do it. That can be a really good way to make sure you get into like all the different like groups within your population. Like if you have groups that you really don't want to leave out. But that's not always super easy. So sometimes what we'll do is we'll do something called a cluster sampling, which is kind of like a modified version. So you still split your population into groups. So it starts the same way. You divide your population up into groups. But then what you do instead is you use a simple random sample to select a few of the groups. So it's like you're not going to go into every single group. What you're going to do is you're going to pick a few groups, and then you're going to sample everyone in the selected groups. Okay, so I'm not going to go into every group, but I'm going to pick a few groups and talk to everyone there. So you still end up with like the same amount of samples. You're just getting more representation from the few groups that you're getting all your representations from the groups that you pick, and you're not getting any representation from the groups that you didn't pick. So. But it's not necessarily like a terrible way to do it because like it might be really hard for me to go into every single math class and survey 3 people. That might be really difficult for me to actually do, like technically, to get it done. And so it might just be easier for me to just randomly pick like 10 classes and go to those teachers and be like, hey, can you give my survey to everyone in your class? And then that would be a stratified approach. And you still use random selection to pick those classes that get picked. That's how you try to get your representation in there. And it's just maybe a little more convenient. But the key is that the random selection happens in both cases. So even if you're using one of these non-random or like a modified random sampling procedures, you still are using randomness to try to get that representation. I don't want to pick the classes that I'm going to go into. I want a computer to tell me what class it's going to. So, yeah? Yeah.
So when you split the population into groups, is how is that split up? Do you just pick random groups?
It's just how, yeah, it's how you, it's depending on what you're interested in. So in the math department example, that might just be I'm splitting it into classes because that's convenient, because they're already split into classes. But I could do it other ways. I could do it like, developmental math classes versus college level math classes versus like our higher level math classes or something like that, you know? So I could split them that way, and then I could use those as my groups. It really just depends on what you're interested in. Yeah, it's not like there's like a standard or something. Yeah. But if you have like, if you have sorry, I feel like I'm going on. Am I losing you guys here? If you have groups that are a small part of your population, but you don't want to leave them out, then stratified sampling works really well. So, like for example, if you were taking a survey of just like Tri-Cities residents, there's certain demographic groups that are you're definitely going to get representation from. So, like say if you're talking about like race or ethnicity, if you just took a random sample across Tri-Cities, you're definitely probably going to get some Hispanics, Latinos, and also some white people, right? That's probably for sure. But there are other ethnic groups in the Tri-Cities that are not as big. They don't represent as much of the population, and you might miss out on those groups unless you divide up ahead of time and make sure that you take a random sample from that group. And so that can be the advantage of a stratified sample. Yeah. So, all right. Anywho, all right. And then systematic is not very interesting, but it's also very convenient, and sometimes it's justifiable. And so in this case, systematic is just that your samples are selected based on a pattern. So it works really well. Like in manufacturing, if I have to like do quality control and kick some stuff off of my assembly line, you could do it randomly, but it makes a lot more sense to do it systematically because of how how fast you can QA items, and so you might just pick every 1,000th item, kick it off the assembly line or something, or you might grid up a map and you just at the crosshair, everywhere that a grid intersects, you're going to go there or something like that. Okay, so. Just some examples. So let's say the city of Richmond, you don't have to write all this down, but let's say the city, they want to do a survey about their recycling services. And so they say, okay, well, what we're going to do is we're going to go to the second house on the right of every north-south running street. That's probably a reasonable way to do it. But what type of sampling procedure would that be?
Systematic.
Yeah, that's just based on a pattern. So that would be a systematic sample. But it's probably not a bad sample because it's probably still going to be pretty representative of the city, right? Because there's probably roads that start in every part of the city, so you're probably going to get pretty decent representation doing it that way. It's not like the worst way to do it. Okay? So let's say instead, what if they split the city into neighborhoods and then they randomly select 15 houses from every neighborhood? What would that be? Yeah. Stratified because you're going into every single neighborhood. And then they can decide how they want the neighborhoods to be split in a way that makes sense to them to make sure everybody's getting represented. Okay? Or if you're gerrymandering, you can design your boundaries to have your survey tell you whatever you want it to tell you. So that'd be stratified. Let's say instead maybe they do the neighborhoods, but then they just randomly select 3 neighborhoods and basically canvass those ones. That's the example of cluster. So, okay. So that's the difference between stratified and cluster sampling. Make sense? Seem okay? Yes.
Just the difference is that cluster is like random.
Yeah. So there's still random selection because the city's they're not gonna decide on their own which 3 neighborhoods to go visit. They're gonna give every neighborhood a number and then let a random number generator decide which 3 neighborhoods they're getting surveyed. So
like the thing you share with the machine.
yeah. Mm-hmm. So if I have like 31 neighborhoods in my city, I just go numbers 1 through 31. Give me 3 random numbers from 1 to 31, and those are the 3 numbers I'm gonna go. Those are the 3 neighborhoods I go and check
The
out.
stratified is random too.
Yeah. Yeah. The stratified is also random though, because within each group you have to randomly select which house you're gonna pick.
Which one was systematic?
Systematic is just based on a pattern.
Oh, okay.
So it's just like, oh, I'm just gonna go to every second house on every street. Boom. That's a pattern. So, okay. What time does this class go till? Now? Okay. I don't know. That's why I was asking you. I forgot what time it went to. 1:40. 1:40. I think it's 1:40. I'm pretty sure. I don't know.
Yeah.
It could be 1:15. It could be 1:15 if you want to make it that. But now I got a little bit. I want to get through a little bit more before we go. Okay. So we kind of talked about this a little bit. What do you think? What are like the advantages of say like cluster sampling? Why is cluster sampling advantageous?
You know, less distance that you have to cover.
Yeah, there's just a few places you can just concentrate on. It's a little bit easier. But what are the disadvantages of cluster? Yeah, it's like you might really miss some big chunks of information out of your population, especially like in the neighborhoods. What if the random number generator just happens to split out 3 neighborhoods that are all right next to each other? And then it's like, yeah. And then as far as, what about systematic? What's an advantage of systematic?
It's pretty random.
It'll get you good coverage. Yeah, is that what you meant, maybe?
Yeah, so
Yeah, and it'll also, what? It's also easy. Yeah. And then what about stratified? What's the advantage of stratified?
Equal representation.
Yeah, you're getting representation across all the groups, but the difficulty could be kind of difficult to do. It takes a lot of effort to get into a bunch of different groups. So, anyways, all things to think about. If you could do it as a truly simple random sample, that's kind of the gold standard, though. You know, go to that. If you could, like for City of Richland, if they could just randomly pull from their database, 100 houses and try really hard to get those 100 houses to participate, that would actually be the best way to do it, because that's truly random. So, all right. The whole point, though, is what we're really trying to do here is we're trying to make sure that the data that we gather is representative of our population, and when it's not, that's when you have bias. So bias occurs when the results of a study are not representative of the population. Okay. So, and bias can happen in a lot of ways. So say you take a survey or whatever. There's a lot of ways that you could accidentally end up with results that aren't representing your population. We already talked about some of them, right? So, like, what are some of the ways we talked about that you could end up with wonky results, like some bad stuff?
cluster.
Yeah. So it could be because you could have like under or over-representation of certain groups. So that could happen in cluster sampling. If you're doing a truly random sample, though, you don't tend to see that happening because since everyone's equally likely to get picked, there's a very high chance that you'll end up with people from all the different groups, just because of the random selection criteria. Okay, so that's one. What are some other ways that you think that bias could be kind of creep into a survey or a study? Yeah, so and that would typically would fall under probably this, is under or overrepresentation of certain groups. Typically that happens accidentally, but you could actually do it on purpose if you really wanted to, if you wanted certain results. That's for sure. What else? Any other things you could think of? So like, let's say I'm going to go out and I'm trying to figure out, I want to take a survey about their bunch of different stuff about parking. It has a bunch of questions on it, like, are you satisfied with parking? Would you be willing to pay blah, blah, blah for this? Or something, there's a bunch of questions. So what are some ways that maybe I could end up with biased results? So we talked besides that. Yeah.
Would it be like if you went and just picked yourself, like if you went to the parking lot?
Yeah, so and that kind of falls under overrepresentation groups, but it happens with non-simple random sample designs. Yeah. So if you don't use a simple random sample, there's a very good chance that you're going to end up with bias. So underrepresenting or overrepresenting certain groups, not using random sampling, that could be a problem. But even if you did use like a really good sampling procedure, what could still happen? Yeah.
I'll talk to all the people that are carpool parking and then a front row. So if you just happen to talk to only those guys.
Well, so that there is something there, and that's just the fact that sample is not the population, right? And that's kind of unavoidable in some way when you take a simple random sample because, yeah, there is some chance that you might just end up with a lot of carpool drivers in your simple random sample just by random chance. And that could skew your results, because you didn't get that representation. So that is a problem. That's one way bias comes in. These are kind of like your fault. This is almost like unavoidable. Just by the nature of sampling, there's a chance that you're going to get something goofy.
Could it be with like what you want to do with the numbers that you've taken? So like, I don't know, like you take all the info, but then you really only talk about there were 60 students that were unsatisfied out of them.
Oh yeah, you could definitely manipulate it at the back end. I was thinking more on the front end before you take the survey, but you could do all sorts of goofy stuff on the back end. Yeah.
I was kind of going to say that.
Okay.
If you phrase just like how you phrase the question.
Well, yeah. So that's something that comes before. So like stuff like poorly worded questions, and that could be intentional. Again, all of these could really be intentional and not intentional. But yeah, if you do a poor job of measuring your information, then the information you get is not useful. So if I ask the wrong questions, or I ask questions that aren't clear, and then you guys are answering those questions, then it's like I'm going to have information, but it's going to be useless. Or it might not actually be telling me what I want it to tell. Yeah. So anyways. Okay, so these all touch on sort of the main types of ways that bias can creep into studies. And so the one that you touched on, just like maybe you end up with lots of carpool people, that would be an example of sampling bias. And this is just bias due to the fact that using a simple random sample to create a sample from population it may end up, not representative just by random chance. Because it's random. The advantage of randomness is that it makes it highly unlikely for this to happen. The disadvantage of randomness is that every once in a while, by random chance, it does happen, and you don't have any control of it, and you never know when it's going to happen. So that's the pluses and the minuses of doing random sampling. So it's great in some sense, but it can also make bad things happen. And that's sampling bias, and you can't do anything about it. That's pretty much what statisticians are trying to control for. That's the main job. It's like, look, you randomly pick people out of your population. We know that your sample is not representative of the populations in some ways, probably. And so how are you going to deal with that? I mean, how are you going to take that uncertainty into account? So, okay? So this one is like, you have no control over this. Deal with it. Right? So it's like the kind of the living in the real world part of statistics. Okay. Okay, so now, even if you go beyond that, and we kind of talked about this earlier, you can have bias in the form of non-response, and we already talked about that. And so what's one way that you end up with non-response, what do you think? Like we talked about surveys, right? So if you allow people to do like voluntary response on surveys, like you let them choose whether to participate or not, then you're introducing yourself to a whole lot of non-response bias, and that's your fault. You should have done that, right? And of course, even if you could go and pick a bunch of people randomly and go try to talk to them, what's going to happen sometimes? Yeah, so, well, that would actually be a response bias, which we're going to talk about in a second. That would be like intentionally deceptive. But beyond that, some people just what? People be like, I'm not going to talk to you, right? You go, like, you want to take a survey? You'd be like, no. Be like, It only take 2 minutes. I'll be like, I don't want to talk to you, right? And so non-response could just be like refusal to participate. So and so really your main job when you're taking a simple random sample is to try to make sure that this happens as little as possible. Make sure that you try your hardest to get a hold of everybody. So that's non-response bias, but that is an example of stuff that you can have some control over, and so you should. Then, of course, there's response bias. Okay, response bias. This could happen in a lot of ways. So that would be an example of like poorly worded questions cause response bias. Because you ask the question in a way that it manipulates the likelihood of them answering the question in a certain, maybe biases it towards one result or the other. So that'd be poorly worded questions. Then if you go, what was the other one? Oh yeah, people lie. So you talked about that one, but up here in the front, it's like people lie. Especially if you're talking about things that like most people wouldn't admit to in public. Like illegal activity or, illicit drugs or whatever, stuff like that. So people lie. So you do have to deal with those ones. But, like, you can correct for people lying. They have procedures and surveys that try to ask questions in multiple ways to see how people respond. If there's inconsistencies between how they answer questions that are getting at the same thing, then you can kind of judge how unreliable the survey taker is.
So is that why, like, when you take surveys, like, you see questions are kind of the same?
Yeah.
And then, like, they kind of see if they give us some answer?
Yes. Especially if you've ever taken one for like have you ever taken one for an employer who's trying to like screen people?
Or like
And it's like a big long survey and it seems like you've answered the same question like 5 times.
Or they do it different times, Like,
Yeah.
they'll do one this time,
Mm-hmm.
and then, like,
That's what the survey is attempting to measure. It's attempting to measure your reliability as a survey taker so that when you answer other questions, they can determine how likely you are to be actually answering the questions honestly versus dishonestly. So it's pretty interesting, actually. Yeah.
So, like how some professors will say if you complete the course survey, you'll get like extra credit.
Yes.
So that would be considered response bias?
I don't know because that's not a random sample.
Because they not factor the part where, like who gives you extra credit, what they want to put good things.
Yeah, right. I don't know. It depends on the professor. Hopefully they were doing it anonymously so they wouldn't know who was tied to what response. But that would be more like, that's a little different scenario because when we're doing student evals, we're not really looking for a simple random sample. We're actually trying to get a population. We're trying to get everyone to take the survey. So it's a little bit different. It doesn't really, that falls outside because it's not like a scientific study. We're just trying to get as many people to participate in the feedback so that we can use it. But anyways, but that's response bias, and I can't even remember what we were talking about anymore. I got way off on a tangent. Feeling very distracted today, but must be Thursday. So then they break down into 2 classes, right? That's the sampling. This is what we were talking about. This is just inevitable. So these are the inevitable types of errors that you have just by the nature of taking a simple random sample, just by the nature of people not people lying, and so this just you can't do anything about it. And then what you have and then the non-sampling errors. These are kind of like these are like the errors that are kind of like your fault, and so that's the things that we talked about before. Like not controlling for non-response, not controlling for whatever. So, okay. All right. What we got? A bit. We can knock it out. We can finish it, I think. So a little bit more on. So this is just going to finish out the modules. So a little bit more on experiments. Just some terminology. We sort of already talked about this, but we didn't talk about some of the ways that we actually do control for lurking variables. So in an experiment, you can have multiple explanatory variables. And you can also have multiple levels of your explanatory variables. So any level of explanatory variable that you're trying to introduce into an experiment, is called factor. Okay, and what happens is, like as an example, like I always use one. If you think about, like, let's say you're doing some experiment on crops, like crop yield, and you think that like water, sun, and fertilizer are maybe 3 explanatory variables. Makes sense, right? But you also might think they interact differently, so you might want to try them at like different levels. And so you might try like low water versus high water, and you might try like low sun and high sun. And then you might also split your fertilizer up to like no fertilizer and yes fertilizer, or something like that, or maybe low fertilizer and high. However you're gonna, however you think it makes sense to split it up, right? And so what happens is each of those are a factor, and because you are designing an experiment, you can think about how your experiment might actually be about fertilizer, but because you know that water and sun are lurking variables, then you can take them into account into your experiment, and you can form different factors so that you can kind of tease apart how those things interact. That's the idea. Then treatments, these are any combination of your factors. Okay? So if you were doing this yourself, you would want to actually make sure that you matched everything up with every other option to see how they interact, because you would want one thing to have low water, low sun, and no fertilizer, right? That would be one group. And then you'd want to have one with low water, low sun, and then maybe yes fertilizer, right? And so this would be a treatment, this would be treatment 1, and this would be treatment 2. So what happens then is you want them, and then but you just keep combining them. There's a lot of them here, right? There's going to be, I don't actually know how many there's going to be 8, because it's two options at each level, so 2 times 2 times 2, I think it's going to be 8 possibilities, the way you can do it. So what happens here is that there's only, there's 3. There's 3 explanatory variables in the example I gave you. So 3 explanatory variables. But there's 6 factors, and there's 8 possible treatments, if that makes sense. So you're really only interested in how 3 things are interacting, but because they can be at different levels, you actually have 6 factors, but because of the way you could match them all up, you're going to end up with like 8 different plots of land set aside to do 8. You're basically running 8 simultaneous experiments, but you're splitting them up so that you can see how they interact. Yeah? Okay. Make sense? Question? Question?
Oh, no, I was just like,
Okay. All right. So it's always really important in an experiment that you have some control group. What is the purpose of a control group, or what is a control group? Anybody know that term? Yeah, it's like the group that stays the same, or so it's the group that stays the same, or it could be like whatever the baseline is, or sometimes it's like whatever sort of the status quo is. So it's like whatever standard practice is. So it could be the group that's getting nothing, like if it's a placebo example, or if it's like, so status quo just means the way things have always been done. So maybe the status quo could be like, in the fertilizer one, it could be like the average amount of rain that your area gets, and the average amount of sunlight that your area gets, and the standard fertilizer that you're already using. That might actually be your control group or something. Okay, and then one way that you need to establish control groups, if you're using humans as your subject, is placebos. right? So what is a placebo?
Something they think is the
Mm-hmm. So it's sort of like a fake treatment. You know, it's like a sugar pill or like a saline injection or whatever. It's where the patient's not actually getting treatment; they're getting, but they don't know that. They know that they could be getting the placebo or the actual treatment, but they don't know if they're getting it, and they're still taking something so that they can't be convinced that they aren't or are, right? So then when you introduce placebos, typically is to cause at least a single blind. So the single blind, this is when the individual is unaware if getting treatment or placebo. You know, or they don't know if they're in the control group or not. So that would be a single blind. And then what do you think would turn it into a double blind? Yeah, yeah, exactly. So in the double blind scenario, neither the individual nor like you said, the experimenter or the experimenter that interacts with them, neither of them knows. So, what's the importance of doing something like that sometimes?
So there's no bias.
Yeah, the bias could come in from the actual person interacting with them, right? So how could somebody interacting with a patient affect them or affect the way they report things? What do you think?
If they like the patient.
Yeah, so I mean, if they like the patient or not, or if them and the patient get along, that could affect how they respond to surveys.
if the experimenters like asking questions more in depth to the person that they know is getting the actual treatment.
Yeah, right, exactly. So like if it's like for like anxiety medicine and I'm relying entirely on patient response and I happen to know that you're getting the pill and then you come back to me and say, oh no, nothing's better, I might be like, you sure about that? Like, because I know you're getting the medicine. Or vice versa. You might be like, I feel great, I'm 100% cured, I don't have any more anxiety anymore. And I'm going to be like, okay, because I'm giving you a sugar pill, so you sure about that? So, anyways. All right. Okay. So, just this one we had already visited, so we'll just go through identifying some of these things here. So, like, this one says 4,500 pregnant women, they were given either a supplement or placebo. Let's say they also group them by age into 35 years older, or 35 years or younger. And what would be the factors here?
Folic acid supplement.
Yeah. So you've got folic acid and placebo, right? So that would be two factors. And then what else do you have?
Age.
Yeah. So you have 32 plus, or you have 35 and under. So there's there'd be four factors in this experiment. And so they would form four groups in this experiment probably. So you'd have the 35 plus getting both treatments, and you'd have the 34 younger getting both treatments, or both yeah. Okay. What would be the control group probably here?
The placebo.
Yeah, it's going to be at least the placebo. Probably wouldn't think of either age group as a control group. You'd probably just treat the placebo group as your control group. Are they using any blinds? Well, they have to be at least doing what?
Single blind.
Yeah, they don't really. I didn't specify here whether or not practitioners knew, but it's at least a single blind because there's a placebo. So anytime there's a placebo, you got at least that. All right. Yeah. Okay. Yeah, we'll stop there. I think that's pretty much it. Yeah, there's only 2 slides, but they're not that consequential. So, but we'll just finish them off next time.